Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of zeros of quadratic functions. This is standard A.7B in the great state of Texas, and we are using item number 18 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find the zeros, because you see I'm trying to find a true statement about this function here, and it's all about what are the zeros, and yet we've got kind of a strange quadratic function here. So what do we know about quadratic functions? Well, we know standard form looks like this. So if we can make it say, and I'll say g of x equals ax squared plus bx plus c. That's our standard form. Here's the problem. I'm seeing this. G of x equals x squared minus 576. You know what I'm missing? I'm missing a b. So we're missing something there. And I know that if I can get it into my factored form, right, my factored form looks like this. G of x equals a, x minus u, x minus v. The u and the v actually are the zeros. But in order for me to do that, I need a b. Because typically, right, what I would do is I would do this diamond method here. So what I would do is I would take my a and my c, right, I would multiply a times c, which, okay, if my a equals 1, my c equals negative 576. Well, I really wouldn't want to try to figure that one out, but it's negative 576. But I need a b here. So this diamond method is not going to work because I don't have any b. It's just not even there. I mean, if you wanted to say b equals 0, how helpful is that going to be if you're going to try to find two factors that multiply to negative 576 and add to 0? We can do it, but that's a kind of a strange way to think about it. So we'll come back to this. It's not the most useful way. What we need to see is we need to go back to our mathematics chart. And we need to go to our mathematics chart and we need to find, under the factoring section, our reference materials, it's called the difference of squares. And this is something hopefully we recognized. So if we see something that says a squared minus b squared, that's really a plus b times a minus b. That ends up with the difference of squares. Well, this is a square, obviously, right? X squared. So I can say x squared, but that minus 576. Is 576 a square? Well, if we take the square root of 576, guess what we get? It's actually 24. Okay, so now we're on to something. So I can rewrite this as x squared minus, instead of 576, I can say 24 squared. Okay? So I can say x squared minus 24 squared, so then I can rewrite it as x plus 24, x minus 24. So you know what? We actually can do it here if we wanted to go back to here, but it's kind of hard to see unless we see that this is a square. If we can see that as a square, then we're good. Then it makes actual perfect sense. But I don't really need to do that now because I've got this in my factored form. And my zeros are going to be the u and the v. Because what you do is you set each of these to 0 and you solve. So x plus 24, well, that's easy. Then one of my zeros is going to be when x is at negative 24. And then x minus 24, well, then the other one is going to be when, if I solve for x, when my x is a positive 24, because these are my two zeros, that u and that v. So that this is going to be x minus u, so in order for that to be a minus, it's going to be minus 24, and that x is simply going to be 24. So we see that we actually have it right there. On h, we do have the correct zeros of negative 24 and positive 24, so my answer here is going to be h.